Here we're going to be evaluating algebraic expressions with exponents. Let's say we have the following expression. We have 4x squared minus 5y. And for this expression, we want to find the value when x equals minus 2 and y equals 9. Okay, so we have the expression 4x squared minus 5y, and we want to know what the value is of this expression when the value for x is minus 2 and the value of y is 9. So how do we do this? And what we do is we're going to substitute the value for each variable wherever we see that variable in the equation, or excuse me, in the expression. So we have 4 times a minus 2 squared minus 5 times 9. We simply substituted minus 2 in for x and 9 in for y. We want to make use of these parentheses so it's a lot easier to see where we're substituting in for the variables. And from here we can simply carry out our order of operations. First we're going to have this exponent to deal with. So we're going to rewrite 4. We're only squaring the minus 2 term. We're not squaring the 4 term. So we want to make sure we have a distinction here. We have a minus 2 squared. Now, we need to be careful when we're squaring a negative term, and I guess it's easier to remember that whenever you square a term, you cannot get a negative. It's always going to be a positive. So whenever you square a term, it's always going to turn that term into a positive. And this makes sense because you're multiplying something twice. Even if it's a negative, it's going to be negative times a negative. In this case, minus 2 times minus 2. And that's going to give you a positive 4. Okay? Make sure you get the exponents down. Squaring a term is always going to give you a positive term. Okay? Now we have a minus 5 times 9. Okay? Now our order of operations says we're going to carry out the multiplication before the subtraction. So we have 4 times 4 is 16, minus 5 times 9 is 45. 16 minus 45, the negative wins out because it's bigger, and this is going to give us a minus 29. Now that means the value of this expression here, equals a minus 29 when x is a minus 2 and y is 9. Let's do a couple more. We want to find the value of the following expression. We have 3x squared minus 2x squared plus 3. Okay, here we only have one variable, but it's in two different places. So we want, let's say x is minus 6. Okay, we can actually simplify this before we do our substitution. We have two terms here with the same variable raised to the same power. So what that means is we can actually combine these two. 3x squared minus 2x squared is a positive 1x squared, or just x squared. And then we have a plus 3 right here. Now we can go ahead and substitute minus 6 in for x. If we did it up here, we would substitute minus 6 right here and minus 6 right here, because we have two x's. Okay? But now we've simplified this before substituting, so we actually only have one variable to substitute in for. So we have a minus 6 in for x squared plus 3. We take care of exponents before addition in the order of operations. So minus 6 times itself is a positive 36. We're always going to get a positive when we're squaring a term. Then we still have our plus 3. 36 plus 3 is 39. The value of our expression is positive 39 when x is a minus 6. Okay? Let's take a look at this one. Let's say we have x cubed times y squared divided by x squared plus y cubed. And here we want to have, let's let x equal 3 and let's let y equal a minus 2. Okay. X is 3, y is a minus 2. So we actually have 2 of each of these variables, so we want to substitute, wherever we see x, we want to substitute a 3. Wherever we see y, we're going to substitute a -2. We're going to do so in parentheses. So x cubed, x is 3, so we have 3 cubed, times y, which is a -2 squared. Be sure we don't forget the square term. X squared, x is 3, so we have 3 squared, plus y cubed, y is a -2, so a -2 cubed. Okay? We take care of our exponents first, so 3 cubed is simply 3 times itself 3 times. So 3 times 3 is 9, times 3 is 27. If you need to write it out, you can write it out simply as 3 times 3 times 3, which equals 27. Do so on the side if you need to. Okay, so we have 27 times -2 squared, so -2 times -2 is a +4. So we have 27 times 4 in the numerator. Down here in the denominator, we have 3 squared, so 3 times 3 is 9, plus, excuse me, we're adding here, -2 cubed. So that's simply -2 times -2 times -2. Now, wherever we're cubing a negative number, we're going to get a negative number. And this makes sense because these 2 negatives can cancel out, and we're still going to have a negative over here. So we're going to get a negative number when you're cubing a negative number. We're going to get a positive number whenever we're squaring a negative number or a positive number. So we always want to keep this in mind. 2 times 2 is 4. 4 times a -2 is -8. So -2 cubed is a -8. Okay, we can treat the numerator and denominator as separate entities. 27 times 4 is 108. And 9 plus a -8 is just 1. And 108 over 1 is simply 108. Okay, so let's be sure we're careful with our minus signs, and we always want to make sure that we're substituting the right value in for the right variable. And I always want to make sure I have parentheses around the value that we're substituting in for the variable, just to make sure that we don't make any mistakes. Okay, let's take a look at another example. Let's say we have the following values for the following variables. Let's say we have x equals a -2, y equals 3, we have z equal -1, and let's say we have w equal 5. Don't get excited about seeing the variable w. It's simply a placeholder just like any other variable. We can use any letter, English alphabet, Greek alphabet, what have you. Okay, let's evaluate the following expressions. Let's say we have 7x cubed. Okay, well, we know what x is. X is a -2, so wherever we see x, we're going to substitute in a -2. So we have 7 times a -2 cubed. We have the cube term. We just saw down here that -2 cubed is a -8. So we handle the exponent first. 7 times a -2 cubed is -8. 7 times a -8 is -56. Positive and a negative multiplied together will give us a negative. Okay, let's do another one. Let's say we have 3x squared divided by 4x squared. Okay, well, we know what x is. We have 2 x's, so let's substitute in -2 in for each x. We have 3 times -2 squared divided by 4 times a -2 squared. Take care of the exponents first, so we have 3 times -2 squared is -2 times -2, which is a +4. Always going to get a positive number when we're squaring a number. In the denominator, we're going to do the same thing. 4 times -2 squared, which we saw up here, is 4. 3 times 4 is 12. 4 times 4 is 16. And let's be sure that we leave our rational number in lowest terms. 12 over 16 is 3/4. Okay. Want to get plenty of these examples in so we get a lot of practice. We want to handle our variables correctly. We want to insert, we want to substitute the values in for the variables, and we also want some practice treating with the exponents. So let's say we have 2z cubed minus 4w squared. Okay, so now we have two different variables here, but we know the value of these variables, so let's plug them in. We have 2 times z, which is a minus 1 cubed, minus 4 times w is 5, and w is squared, so 5 squared. Okay, let's handle the exponents first. They come first in the order of operations. Well, they come before multiplication and subtraction. We have 2 times a minus 1 cubed. Now, remember what we said earlier, that when we're cubing a negative number, we're going to get a negative number. So minus 1 times minus 1 times minus 1 is going to be a minus 1. Okay, be sure to write it out like this if you need to. Now we have minus 4 times 5 squared. 5 times 5 is 25. Minus 1 times 2 is a minus 2. Minus 4 times 25, which is 100. And let's go ahead. We're subtracting a positive number from a negative number, so let's do plus a negative, so they're both negatives, and we can combine them. Minus 2 and minus 100 is a minus 102. All right, we're running out of time. Let's do a couple more examples. Let's say we have 3x squared minus 2x squared plus 4x minus 2. All right, we only have one variable, but it appears 3 times. Now, as we saw over here, we can combine these 2x squared terms and simplify as we go. We always want to simplify as we go. It makes calculations much easier. We saw over 3x squared minus 2x squared is just x squared plus 4x minus 2. Now we can't combine these two terms because we have an x squared and just an x, so we can't combine the coefficients. So what we're going to do is we're going to substitute the value minus 2 everywhere we see for x. So what we have is minus 2 squared plus 4 times x, which is a minus 2, and we have our minus 2 term. Lots of minus 2's. So let's be sure we put our parentheses around our substitutions so we don't miss anything. Minus 2 squared is a positive 4 plus 4 times a minus 2 is a minus 8. Then we have our minus 2. And we can do all three of these terms in one step if we want to. 4 plus a minus 8. The negative wins out, so we have a negative 4. Negative 4. Let's go ahead and write this out so we don't miss anything. Negative 4 minus 2. We can go ahead and add a negative, so we can combine our negatives. Minus 4 and minus 2 is a minus 6. Okay, let's do another one. Let's say we have 8 plus 1 over x cubed. Okay. We have one variable, so we're going to plug in for x. We're going to plug in minus 2. So we have 8 plus 1 divided by minus 2 cubed. Okay, order of operations says that we handle the exponent first, so we have 8 plus 1 divided by minus 2 cubed, as we saw up here, is a minus 8. Okay, let's go ahead and get a common denominator here since we're adding fractions. We can treat this as an 8 over 1, and we can turn 8 over 1 into 64 over 8. If you need a refresher on finding a common denominator, go back and rewatch the videos on adding rational numbers and get a quick refresher on that. Now we're adding a 1 over minus 8. 1 over minus 8 is the same thing as a minus 1 over 8. Okay? So what we're actually doing is we're adding a negative here. So plus a minus 1 over 8. And we simply subtract across the top. We're adding a negative, so we're subtracting. 64 minus 1 is 63. And we just rewrite our denominator since we're just adding. So we leave it over 8, and 63 over 8 is our answer. Okay, I'm out of time, but let's review really quick what we learned here. Evaluating the algebraic expressions with exponents is just more practice on plugging in the variables that are defined for the given values. We want to plug in the values, put parentheses around them, and we always want to make sure we're handling the order of operations in the correct order. Exponents being exponents are very high up there. They're right after parentheses, so be sure we want to handle those before we actually carry out any other operations. Okay, we're out of time, and I'll see you soon.